Hey, what's going on guys? It's Ila Bailey here. I record stuff on YouTube, chat description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it, and this is called minimum number of vertices to reach all nodes. Given a directed acyclic graph with n vertices number from 0 to n minus 1 and an array edges where the value at the position of I in this array is equal to from I to I represents a directed edge from I to node to I. So from I means an incoming edge, to I means an outgoing edge. Find the smallest set of vertices from which all nodes in the graph are reachable. It's guaranteed that a unique solution exists. Notice that you can return the vertices in any order. Okay, well, let's look at those examples. Here we got a directed graph. As you can see, there are those arrows, okay? Which means, for example, here we get 0, 1. We are able to reach 1 from the position of 0, but not otherwise. Okay, we cannot reach 0 from the position of 1. N is equal to 6 edges. Okay, those edges you can see. So 0 and 3 are unreachable. Okay, we are not able to reach those vertices, those nodes. By the way, nodes in the graph are called vertices. Okay, hope you know that. And yeah, so we cannot reach those vertices, those nodes from any other node in the graph. That's why we include them in the final result. Yeah, here that's the same. We include 0, 3 and 2 because 0, 3 and 2, right? Because we are not able to reach those nodes from any other node in the graph. Let's look at these constraints. The number of vertices, which is n, is within the range of 2 and the base 10 raised to the power of 5, inclusive the number of pairs edges is between 1 and the minimum value the base 10 raised to the power of 5, or n times n minus 1 divided by 2. Okay, we pick up the minimum value. We got an incoming and outgoing edge. Okay, edges is equal to 2. Okay, 2 edges. Yeah, 2 types of edges. Okay, incoming and outgoing. From I to I. Okay, between 0 and n here is equal to, is less, okay, is bigger, is greater or equal to 0 and is less than n, the number of vertices. All pairs from I to I are distinct. Well, we can reach our goal, we can solve this problem by creating a list. Okay, go for it. We can create a list, the type integer, just call the result, new array list, type integer. At the end of this method, we're gonna return that list, and we are going to create an empty array, which is gonna be called like scene or something, you know, like int scene is equal to new integer. The length of this array is equal to the number of vertices, and and we are going to iterate through all those edges in the graph, and every time we see an outgoing edge, outgoing vertex, whatever you call it, we mark the value at the position of that outgoing vertex as seen, as 1. Okay. um, otherwise we just ignore that, we ignore the vertex and go further. So initially all values in this array are zeros. That's by default in Java. We got indices that start from 0, 1, 2, 3, 4, and so on and so forth. So yeah, that's what we're gonna do. And after that point, we know that some vertices are unreachable. Okay, and we're gonna include those vertices that are unreachable in the final result. Yeah, otherwise if, for example, all the vertices are reachable, we return an empty list res. Okay, that's the point. We need to include all unreachable nodes, all unreachable vertices. Go for it. So the time complexity for the solution I'm showing you is, I would say, big of E plus V, where E is, E means edges, V means vertices, and the space complexity is linear. Okay. Here we create a loop, for loop, and we are iterating through those edges. E means an edge, edges. Okay, edges. Okay, edges. So 1 means an outgoing edge. Okay, or vertex, whatever you call it. 0 means an incoming edge, vertex. Yeah, and like outgoing edge, you can say like outbound vertex. This is an inbound vertex, inbound edge, outbound edge. Like you can call that whatever you'd like. And here we mark the value as seen in this array seen, which is at the position of we got an edge. Okay, dot get 1. So indices start from 0, and outgoing edge is gonna be an outgoing vertex is gonna be here at the position of 1. Okay, at this point here we know, as I said before, we know that some vertices can be unreachable. Okay, and we are going to include them in the final result. We say for, we create another for loop, and we are iterating through those values in scene array, starting from 0. I is less than n, the number of vertices, the length of this array, I plus plus. Yeah, so every time we see that the value at the position of I, the current position, is equal to 0, which means that the node, the vertex, is unreachable, we put that vertex, okay, into that already created list res. So the positions in this, okay, in this array scene, those indices are representing the vertices in the graph. Yeah, and finally return the results. That's it. Let's run this code. That's gonna work, I know that. Accepted, good. Let's submit. Nice, success. Let's look at this example. Here we got 5 vertices, edges are here, you know, this is 0, 1, 2, 3, and 4 indices. 0 at the position of 0, 1 at the position of 1, 2 at the position of 0, 1 at the position of 1, 3 at the position of 0, 1, 0, 1, 0, and 1. So, for example, in order to get to 4, we say this array, like edges, you know, edges. We say, let's say we want to get to 4, okay, we say edges, for example, 3, okay, which means the 4th block, and the position of an outgoing edge vertex, you know. Yeah, so here we create an empty list res, okay, we got no elements here yet. Scene has the length of we have 5, okay, we have 5, so the length of 5, we got zeros here, okay, all zeros by default in Java. 5, yeah, 5, okay, 5, and you know, 5 means the length of this array. So here we are iterating through those ages. We are currently at the position of 0. We can see that the value at the position of 1 in the first block is 1, which means that this vertex or edge, whatever, is outgoing. Okay, we put 1 into this array scene, okay, at the position of this outgoing edge, which is 1. Okay, here we got 1. We go to the next block, which is here, the next edge. We can see that the value at the position of 1 1 is 1, so we modify the value at the position of 1. We again have 1, nothing has changed. We go to the next edge, we got 1, again we modify. Okay, so we modify the value at the position of 1. We have 1. We go to the next edge, we got 4. Okay, so we modify the value at the position of 4. We got 1, which means that we just saw the the outgoing edge, outgoing vertex. We go to the next one, which is we have 4. Okay, we modify the value of the position of 4. We get 1 again. We out of that loop, and at this point of time we can see that the edges, the vertices, okay, the vertices that are unreachable are 0, okay, 2 and 3. Okay, so here we just include we are including those nodes, those vertices in the final results. We are iterating through this scene array, and every time we see 0, an unreachable vertex, we put that into the final result. Okay, for example, here we got 0, we put that into the final result. Here we got 1, okay, we skip that value. We got 2, okay, we got 3, we got 1, we skip that value, and we out of that loop. So those indices, okay, these indices are representing the vertices of the graph. Okay, yeah, finally we return this list containing all those unreachable vertices. Yeah, thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias. Follow me on Instagram, on Snapchat, and I wish you, as always, all the best. Bye.